Moving on to the next question, on question 3 on part 7e. Assuming that the probabilities of a kitten being born male or female are the same, what is the probability that the litter of 4 kittens, there are 2 male and 2 female? So, the event in this case is that when there are 4 kittens from a mom cat, that there are 2 male and 2 female. So that's male, male, and then 2 female, 2 females. All right, let's have a look. So I'm going to show you how I can visually represent this. And there are multiple ways to represent it, and the way you do it is up to you. There's no certain specific way. In this chapter, we work heavily with Venn diagram and tables, so sometimes other diagrams also work. And for this one, I'm going to use a tree diagram. Usually tree diagrams are generally used for like ancestral tree where there's a family and a child and child's child where it's all related. This one's not specifically, but in a way that it shows visually how it works very well, so I decided that I'll show you this way. Let's have a look. So we have a mom cat, meow. This mom cat for the first child and second child and third child and fourth child can have male and babies. To save time, I've already done that for you. It may sound and it may seem a bit overwhelming. Let me go through them by one with you. So for the first child, this mom cat can have either a male cat or a female cat. So there's 2 possibilities. So there are 2 possibilities, and it's the first child. Now, after the mom had the first child, let's suppose that mom had a male kitten. The second kitten can be either a male or a female. Yeah. And if the mom had a female for the first one, the second can be also either male or female. So now, after having 2 kittens, there are 4 possible ways. So, and then we move on. Third one could be also male, female, da 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 da. And what we can notice is if we complete this tree diagram all the way to the 4th column for the 4th kitten, 4th child, there are a total of 16 kittens, 16 combinations of kittens, 16 possible combinations of 4 kittens. And have a look, it's like this. First one being male, second one being male, third one being male, fourth one being male. And if the question was, what's the probability that when there are 4 kittens, they're all male? Then what you would do is, well, there's one combination out of everything over, there are 16 in total, so the probability will be 1 over 16. If the question asked you, what is the probability that is 3 males and 1 kitten, for example? Well, it could either be 3 males and 1 kitten, or it could be male, female, and male. That would be the only way that there are 3 males, right? Because no other pathway has, oh, actually, it could be, I stand corrected. It could be male, female, male, male. Or it could be female, male. All right? So, just like how we did, we are now going to count and show what combinations there are to have 2 males and 2 females. The question did not specify the specific order that it must have first child to be male. It didn't say that. It just said in any combination there are 2 males and 2 females. So let me show you. First one is male, female. The next one could be male, female, or male, female, male. If the mom cat had female child at the beginning, it could have male, down to female, because we need 2 males and 2 females. It could also be like that, female, male, male. the mom cat could have female and also another female for the second one. Then, because there's already two females, the rest has to be just two males, male, male. So now let's have a look at how many possible combinations there are. There are 1, 2, 3, 4, 5, and 6. So now we have 6 possible outcomes for this event to be true. And those possible outcomes, the set, has been written into a set form on the right. Male, male, female, female, male, female, male, female, male, female, female, male, female, male, male, female, female, male, female, male, and female, female, male, male. And this is just written alphabetically, in alphabets rather than shown visually. They are essentially the same thing, but represented in two different ways. And now, therefore, to answer the question, what is the Oops, I spelled probability wrong. Probability. Now, probability is the number of event happening over a number of sample space, as we touched based on last lesson. And we have just figured out number of events happening is 6, and number of sample space is 16, because there are a total of 16 possible combinations. And therefore, if we simplify this, the probability will be 3 over 8. Now I would like you to either rewatch this video or continue on with your exercise 7E, question 1 and 6. Good luck.